Acephysics.org, Math and Physics Tutoring with Dr. Hudis. Hi! The question I'm asking today is, when an ice cube is placed in a glass of water and allowed to melt, what will happen to the water level in the glass? Will it rise, fall, or remain the same? Here's an ice cube floating in a glass of water. When the ice cube melts, will the water level stay the same, the black arrow 2? Will it move up to the red arrow 1, or will it go down to the yellow arrow location 3? You may want to pause the video and think about the answer, because I'm going to tell you the answer right now. The answer is 2. The level of the water will remain the same. First of all, as water freezes and turns into ice, it expands and takes up more space. That's why ice floats on water. We also need to know Archimedes' principle, which states that a body immersed in fluid experiences an upward force equal to the weight of the fluid displaced. So here's the ice cube, and this is the shaded region is the area of the fluid displaced. There would be water in that location, but it's been displaced because there's ice there now. Above the water level, there's ice, but that's not fluid displaced because there was never fluid there to begin with. The forces acting on this ice are the gravity pulling the ice downward, because the force of gravity pulls everything downwards, and that's equal to the weight of the ice. And then there's a buoyant force upward, which is Archimedes' principle, and the buoyant force upward is equal to the weight of the water displaced, which is just the area, the shaded area. It's just that the smaller area. And you can say net force equals mass times acceleration. This is the forces acting on the ice. This is equal to 0 because the ice is not accelerating. And there are two forces acting on the ice. If you want me to explain it in more detail, please let me know within the comments. The main idea is when the ice melts, it shrinks and takes up less volume, and for that reason, the water level doesn't rise. This is a picture from Wikipedia, and this shows an iceberg which is floating in the sea, and you can see a large part of the iceberg is underwater. Of course, the sea is made out of salt water, and salt water is heavier than fresh water, and therefore the buoyant force is larger if you're in salt water than if you're in fresh water.
My name is Adam Trebeck. I'm a PhD candidate here at MIT in the physics department.
And you're about to graduate soon, right?
We hope.
All right.
I have this gut feeling that the water level stays the same, but I'm going to try and derive it in terms of buoyancy. Can you hold this? The mass of water displaced is going to have the same total mass as the ice cube. So then when the ice cube melts, that's the exact same amount of water that's going to be added to the system, so the water level will stay the same.
That is absolutely the correct answer.
Understand the question.
Okay, so great.
Okay, so there's two things to think about. We have to think about the displacement of
buoyancy of ice and displacement.
Right. So water is bigger when it's frozen, right?
Yes.
So
less dense.
So if it's bigger when frozen, it melts. It takes up more space now.
But the
less dense.
displacement caused by the ice as it's floating in the water
Right. Is equal to its weight. Weight's going down.
The question is, does the cup go up or down?
Does the water level go up or
Does the
down?
water
Okay,
level-
so what did you say? You said what you said was right. So you said
Right,
something
right.
good. You said I don't remember what you just said. That what was it?
So I know the buoyancy force is proportional to the weight of the volume of the ice cube, right?
Wait, the buoyancy force is related to what?
The volume of the ice cube, with how much, or the weight of the ice cube and how much volume of water it displaces.
The amount of water it displaces. The buoyancy force is the amount of water it
The whole
displaces.
Eureka.
Yeah, right. The whole Eureka. You just got naked and ran around the streets.
Right.
So does ice weigh more or less? Does the same volume of ice?
Ice
weigh
is
more?
less dense.
Ice is less dense. Does that help at
I
all?
feel like water level should go down, right? Is that right? Because I'm thinking about the opposite. You know the interview question with the rock, and you
I
throw it
know,
off
I'm
the
thinking
boat,
about the
and the
exact
rock
same
is more dense than the water,
Yeah.
and that's why the water level goes up. So here I'm thinking it's the opposite situation. So I want to say it goes down.
Alex?
And you're a postdoc here at
I'm a
MIT?
postdoc here.
And you did a PhD at Berkeley?
Correct.
What was your PhD on?
Theoretical condensed matter physics.
Okay, great.
The amount of water that an object displaces, it's equal to sorry. You can do the volume of water that will have the same mass, and when it melts, it's exactly the
Perfect.
that volume. Yeah.
Yes, that's perfect.
I'm Yi Chen.
And where are you from?
I'm from China.
And what do you study?
Chemistry.
Chemistry?
Yes.
What year are you?
I'm a second year grad student.
Oh, you're a grad student?
Yeah.
Here's a question.
Yeah.
This is a cup,
Yeah.
and there's water in the cup.
Oh, they remain the same, I guess.
Okay, can you explain it? Can you explain?
So-
So you understand the question, right? Okay.
So I think so the volume of that so the force that supports the ice to to flow in on water is provided by the should be equal to so force is like the density multiplies to G and V. So that's the force that provided, and wait, I guess I need paper
But
to write something.
You got the right answer.
Yeah.
Is it that you're having a hard time saying it in English, or do you not really know how to? In your head, do you understand it?
I mean, if I have a paper and I
Okay.
write something on it,
Okay.
I guess probably I can like tell you, but
Yeah.
I forgot like how I get the I directly get the answer. You know.
Okay.
Oh, I'm Sam.
And what year are you?
I'm a first year.
You're first. You just got here.
Yeah.
Where are you from?
I'm from San Antonio, Texas,
Okay.
but originally born in Ethiopia. So
How's your first semester?
it's good. It's as hard as everybody says it is. Okay, so the way I'm thinking about this is the amount. I know that the amount of water it displaces should be the
Well, what were you about to say? The amount of
Okay.
water it displaces should be what?
The amount
that's
of
a good thought process.
Yeah, I was thinking. So it's basically the percentage of the ice cube that's within like the water is like its density relative to the water, I guess. And since since the ice is less dense, I assume that the amount of water should fall.